What are data classes and how are they different from common classes? With PEP 557 data classes are introduced into Python's standard library. They make use of the data class decorator and they are supposed to be mutable nometuples with default, but I'm not really sure I understand what this actually means and how they are different from common classes. What exactly are Python data classes and when is it best to use them?
Data classes are just regular classes that are geared towards storing state, rather than containing a lot of logic. Every time you create a class that mostly consists of attributes, you make a data class. What the data classes module does is to make it easier to create data classes. It takes care of a lot of boilerplate for you. This is especially useful when your data class must be hashable, because this requires an _hash_ method as well as an _eq_ method. If you add a custom _repr_ method for ease of debugging, that can become quite verbose. With data classes you can reduce it too. The same class decorator can also generate comparison methods, _lt_, _gt_, etc., and handle immutability. Nometuple classes are also data classes, but are immutable by default, as well as being sequences. Data classes are much more flexible in this regard, and can easily be structured such that they can fill the same role as a nometuple class. The PEP was inspired by the Utris project, which can do even more, including slots, validators, converters, metadata, etc. If you want to see some examples, I recently used data classes for several of my Advent of Co solutions. See the solutions for day 7, day 8, day 11 and day 20. If you want to use data classes module in Python versions is lower than 3.7, then you could install the backported module, requires 3.6, or use the Utris project mentioned above.
Overview. The question has been addressed. However, this answer adds some practical examples to aid in the basic understanding of data classes. What exactly are Python data classes and when is it best to use them? Code generators generate boilerplate code. You can choose to implement special methods in a regular class or have a data class implement them automatically. Data containers, structures that hold data, for example tuples and dicts, often with dotted, attribute access such as classes, nometuple and others. Mutable nometuples with default s. Here is what the latter phrase means. Mutable, by default, data class attributes can be reassigned. You can optionally make them immutable, see examples below. Nometuple, you have dotted, attribute access like a nometuple or a regular class. Default, you can assign default values to attributes. Compared to common classes, you primarily save on typing boilerplate code. Features. This is an overview of data class features, TL, Dr. See the summary table in the next section. What you get. Here are features you get by default from data classes. Attributes plus representation plus comparison. These defaults are provided by automatically setting the following keywords to true. What you can turn on. Additional features are available if the appropriate keywords are set to true. Order. The ordering methods are now implemented. Overloading operators, is lower than is greater than is lower than or equal to, equals, similarly to functools.total_ ordering with stronger equality tests. Hashable, mutable. Although the object is potentially mutable, possibly undesired, a hash is implemented. Hashable, immutable. A hash is now implemented and changing the object or assigning to attributes is disallowed. Overall, the object is hashable if either unsafe_hash equals true or frozen equals true. See also the original hashing logic table with more details. What you don't get. To get the following features, special methods must be manually implemented. Unpacking. Optimization. The object size is now reduced. In some circumstances, _slots_ also improves the speed of creating instances and accessing attributes. Also, slots do not allow default assignments, otherwise, a value error is raised. See more on slots in this blog post. Summary table. Plus these methods are not automatically generated and require manual implementation in a data class. _ni_ is not needed and thus not implemented. Additional features. Post initialization. Inheritance. Conversions. Convert a data class to a tuple or a dict, recursively. Limitations. Lacks mechanisms to handle start arguments. Working with nested data classes can be complicated. References are Hettinger's talk on data classes, the code generator to end all code generators, T. Hunter's talk on easier classes, Python classes without all the cruft, Python's documentation on hashing details, Real Python's guide on the ultimate guide to data classes in Python 3.7, A. Shaw's blog post on a brief tour of Python 3.7 data classes, E. Smith's GitHub repository on data classes.
From the pip specification. A class decorator is provided which inspects a class definition for variables with type annotations as defined in pip 526, syntax for variable annotations. In this document, such variables are called fields. Using these fields, The decorator adds generated method definitions to the class to support instance initialization, a wrapper, comparison methods, and optionally other methods as described in the specification section. Such a class is called a data class, but here's really nothing special about the class. The decorator adds generated methods to the class and returns the same class it was given. The data class generator adds methods to the class that you'd otherwise have to define yourself, like _wrapper_, _init_, _lt_, and _gt_.
Consider this simple class foo. Here is the dir built-in comparison.
On the left-hand side is the foo without the data class decorator, and on the right is with the data class decorator. Here is another diff, after using the inspect module for comparison.